So for this lesson, we are going to be looking at some of the parent functions that we will be working with this year. This is by all means not all. And we will also be looking at function transformations. So the four parent functions that we're going to look at today are, first of all, the constant function. That is just a horizontal line across the graph. It's always y equals of whatever number the line is crossing on the y-axis. So that's why we call it a constant function, because it is just a number and that is all. And then we have the linear function. So your linear function is just y equals x. At least that's how it starts out. But that is what you talked about all through Algebra 1, so you should be very familiar with a line. In fact, the equation that you guys probably know off the top of your head is y equals mx plus b. But that is, of course, very common. Absolute value, we will dig into a little bit more actually in this unit, but it is also a function that you dealt with a little bit in Algebra 1. So it creates that V-shaped graph, and it always has just those big long bars. And so that parent function is the absolute value of x only, and then of course transformations are what make it move into different places on the graph. And then one that you're probably not as familiar with, you probably looked at it a little bit at the end of Algebra 1, but that is the quadratic graph. In future units, we will be taking a deep dive into quadratics. But that creates a U-shaped graph, and then the parent function is x squared. So these are the four parent functions that we will be dealing with today. And so we will be using them to find function transformations. So for transformations, we have a few rules, and you probably did look at these a little bit in Algebra 1, but probably not in depth. So you have, first of all, your vertical translation. So your vertical translation is a shift up or down. And so this is always added or subtracted at the very end of the function. So if it is added, you are going to shift up k units. And then if it is subtracted, you are going to shift down. So horizontal translations are a shift left or right. So this will always be inside a grouping symbol, and it will always be added or subtracted. But it does work backwards of what the vertical looks like. So if you are going to shift to the right, then h has to be less than 0 or be a negative number. So you will have a minus h inside those parentheses. And then if you shift to the left, you will have x plus h. And so h will be greater than 0 or be a positive number. Now reflections are some of the easiest things to spot because you are just dealing with a negative. So if that negative is in front of the function, you will flip upside down over the x-axis. And then if you have that negative inside a grouping symbol, then you will flip across the y-axis or from side to side. The only functions that you're really going to see this with probably right now are the linear functions. This is actually what changes your slope and kind of makes it look like it's going downhill instead of uphill. But your linear function is the only function that is not symmetrical over the y-axis, which we will be talking more about symmetry here in the near future. So let's go ahead and look at our other two. So we have first horizontal stretch and compression. Again, this is in the grouping symbol. So it does work a little bit backwards. So if B is greater than 1, then you have horizontal compression, which means that it looks like you're squishing it toward the y-axis. And if it is a fraction or a decimal, so it's between 0 and 1, then you have horizontal stretch. So it's pulled away from the y-axis. And you always use the reciprocal to express this one. So you always flip that number over. Then we have vertical stretch and compression. So vertical stretch and compression is always right in front of the function. So it's always easy to find. So if A is greater than 1, then you have vertical stretch, which means that you are going to pull it like a rubber band. And then if it is between 0 and 1, you have vertical compression, which means that you are going to stretch it, or not stretch it, but squish it like you would a pop can on the ground. So it should get shorter. All right, so now for our examples here, we are going to identify the parent function, and then we are going to describe the transformation as it relates to the parent function. So for number 1, we are looking at the g of x equals x plus 2 squared minus 4. So the parent function here is f of x equals x squared. So that means anything that is not x squared is a transformation. So we have, first of all, the plus 2. That is inside a grouping symbol, so it's horizontal. And so since that is plus 2, we are going to shift left 2 units. And then we have a minus 4 that is at the very end. This is a vertical translation, and that is going to shift us up. Or actually not shift us up, shift us down 4 units. And then with number 2, we have the g of x equals the absolute value of x minus 3 and then plus 7. So our parent function here is f of x equals the absolute value of x. So just a quick reference here, number 1 was quadratic. And then number 2 is an absolute value. So we have that -3 that is inside the absolute value, that is going to shift 3 units to the right. And then we are going to shift up 7 because of the +7 at the end. So then with number 3, our parent function, we have just that x. So our parent function is f of x equals x because it's a linear equation. So we have, first of all, that reflection, that since that negative is in front of everything, then we are reflected over the x-axis. And then that 2/5 is in front of the function and not in a grouping symbol. And so you have vertical compression by a factor of 2/5. Then for number 4, our parent function is f of x equals x squared. So this is a quadratic. So for this function, you have that negative. And so this is a reflection over the y-axis. And we know that this is a reflection over the y-axis because it's inside the grouping symbols that are squared. So since we're in those parentheses, then that 2.5, that is horizontal shrink or horizontal compression. And then we need to flip that number over in order for it to be described correctly. So we would need to use the reciprocal. And so we'd have 1 over 2.5, which would be as a proper fraction or a decimal 0.4, which is actually 2/5. So either the decimal or the fraction is fine, but you definitely don't want to use 1 over 2.5. I'm going to go ahead and use the fraction by a factor of 2/5. Then for number 5, we have a few more transformations here, but the parent function is f of x equals absolute value of x. So this is an absolute value. And so we have a total of 4 transformations here. So first of all, that negative. This is a reflection over the x-axis. And then next, the 2/3. That is vertical compression by a factor, that looks terrible, of 2/3. Then the +3 inside the absolute value, that is a shift 3 units to the left. And then finally, the +1 on the very end is a shift 1 unit up. And then number 6. Our parent is actually a linear function. Okay, and so we have a few things happening here. So first of all, we have that negative on the outside. And so this is going to create a reflection over the x-axis. And then we are going to have next that 0.4, since it's inside the grouping symbol, it is going to be horizontal stretch, since it is between 0 and 1, by a factor. And then we are going to have to use that reciprocal. So that's 1 over 0.4, which is actually 5 over 2. So a factor of 5 over 2, and actually I did skip a step in how I got that, because when you divide, you should get 2.5, which is 5 over 2. And then that last transformation there is the +2. And so that is a vertical shift. So you are going to shift up 2 units. Actually, you won't go up 2 units. What am I thinking? You are going to the left 2 units. All right, so now we are going to go backwards from what we were doing. So we're going to transform the given function as described by writing the resulting function as an equation. So we're given our parent function on number 7, and we're essentially going backwards from what we were doing before. So we are going to expand vertically by a factor of 3, which is a vertical stretch. So we will start out as f of x equals, actually we can go ahead and change this to g of x, is 3 times the absolute value of x. And then we're going to translate to the left 2 units. So g of x is going to equal 3. And then since we're going left 2 units, this is going to be x plus 2. And there we go. So that's all we need to do to it. So then, on number 8, we will take our f of x equals x squared as our parent function, which is our quadratic, and we will compress it vertically. So that will be by a factor of 3. So this should actually be a 1/3. So, because anytime you compress, it needs to be between 0 and 1. So we are going to first of all have g of x be equal to 1/3 in front, x squared. And then we're going to reflect it across the x-axis. So we'll have g of x equals negative 1/3 x squared. And for number 9, we're going to compress horizontally by a factor of 2. So we always need to use that reciprocal, but in this case, the way that this is listed, we are going to just use that 2, because remember, to compress, then this is our b value, and it needs to be greater than 0. So we will actually use that 2. So we will take g of x, and we will have the absolute value of 2x, and then we're going to reflect across the x-axis. And that will be a negative in front. And so we'll have the negative absolute value of 2x. For number 10, we are going to take the f of x equals x squared as our parent function. So we'll have the g of x equals, and we're going to expand vertically by a factor of 3. So this is going to be 3x squared. And then we're going to have a reflection over the x-axis. So that is going to be just a negative in front. So we have the g of x equals a negative 3x squared. And then we're going to translate it to the right 3 units. So this is going to go on the inside of a grouping symbol. Since we don't already have one, we're going to have to add some. So since this is quadratic, we're going to leave the negative 3 on the outside. And then in the parentheses, we're going to have x. And since we're going to the right, it's going to be minus 3 squared. Okay, and here's just a quick recap of everything. Pretty much just condensed. So if your parent graph is y equals x squared, then your A is your vertical stretch. And then your B is that horizontal stretch and shrink. And then your C value is also inside the parentheses because it's a horizontal shift. Notice everything horizontal is inside the parentheses. And then your vertical shift is on the end.